Yeah, hello students. Today I'm going to show you how to test any function for continuity and differentiability. What is continuity actually? If the graph of a function continues and there is no break, so there are two stages to prove whether a function is continuous, to test, sorry, instead of prove, to test whether a function is continuous or not, and if it is continuous, whether it is differentiable or not, right? This is in 5.12 of AAHL syllabus, where it says here, see, informal standing of understanding of continuity and differentiability of a function at a point, right? So this part of the function, this part of the syllabus we are going to test today. Okay. Okay then. So look here. What is continuity? So let us see the definition of continuity. A function f is continuous at x is equal to a if f of a and limit x tends to a f of x exists and are equal. Now this first definition is for a function where there are no piecewise parts of a function, or where there is no uh, inequalities as the domain of the function, right? Okay. For a simple function, this is the definition of continuity. But if you have piecewise function like this question, which is on the thumbnail of my video, my lesson. So for that, f is also continuous at x is equal to a if a is the left end point of an interval on which f is defined and f of a and limit x tends to a plus f of x exists. Now look here. What does that mean? And they are equal. Or a is right end point. Okay, this is left end point and this is right hand point of an interval on which f is defined and f of a and limit x tends to a minus f of a exists and are equal. Now look here, let me explain to you this definition. See, f is defined. What does that mean? F is defined means f is a real function on a given interval, right? Then here we said the definition says a is the left end point. What is the meaning of left end point? Look here, and then we find limit x tends to a plus. So for this function, okay, for this part of the function, this is a piecewise function. Here we are going to use plus, okay, a plus or 1 plus, whatever you call it. Now look here, this is left end point. What is the meaning of left end point? See, this interval means what? It starts with 1 and then there may be many values 2 and 3 and so on, because it is a real number. So many values are there. Now, at which point we are going to test? At this point. And which is this point? This point is left end point. So because of that, it is required in the definition, right? It is the left hand point for 1 plus, right? Okay. Then A is a right hand point. Now look here, for this interval, how is the interval? 1 is included, then so many things 2, then so many things 3, and so on. Okay. Now in this interval, okay, in this interval x is less than, sorry, oh, let me rewrite. X is less than or equal to 1, so the right end point is included, and less than that maybe 0, maybe minus 1, maybe so many values are there. So on which value we are going to test? We are going to test on this value 1, and this value 1 is what? This is right end point. Look here, this is on the right side. So in this interval, this point 1 is the right end point, isn't it? So that is the meaning of this definition. So I hope you understood this. Okay. Here we take right end point, and here we take left end point. Okay. Right. I hope you understood this. So if left end point and right end point, so left end point will be A plus and right hand point will be A minus. Okay. See, if you have certain value here, A, x is equal to A, then we test x tends to A minus. So A minus means we take right hand point. We go from the negative side. X tends to A minus. Okay. And this is the right end point. And if we come from the right side, we call it x tends to A plus. Okay. A minus and A plus. Here by mistake I wrote x tends to A to the power minus 1. It is not A to the power minus 1. If we are coming from the left, I'll again explain. We take limit x tends to A minus. Okay. If we are coming from the left side, and this is the right end point. And if we are coming from the right side, we take limit x tends to A plus. Okay. Because we are coming from the right side. And this is left end point. This is right hand point. So both the things are explained here. See here and here. Left hand point and right hand point. Okay. So I hope you understood this definition. Right. So if both the limits are equal, left hand limit and right hand limit, in short, we call them left hand limit and right hand limit. So I wanted to write here actually, we call, when we find limit here, we call it left hand limit. And to this we call right hand limit. Okay. Right. So I'm sorry for the disturbance of the screen. Sometimes it happens. Okay. Okay. So now look here. I'm finding this limit. This limit at what point we want to test? See, this question says test for the continuity and differentiability of the following function at x is equal to 1. Okay. So at x is equal to 1, we have two parts of the function. This is called piecewise function, right? Piecewise function. So this is the left hand limit part. This is the right hand limit part. Okay. Now look here. I am finding limit x tends to A minus because at 1 we want to test. So limit x tends to 1 minus. This minus is not the negative sign, but it is symbolic. It means we are coming from left towards x is equal to 1. On the number line, there is a point x, and we are approaching x is equal to 1 from the left side. So we write limit x tends to 1 minus. Okay. So for this part, we write x tends to 1 minus f of x, which will be limit x tends to 1 minus x square, right? And whether it is 1 minus or 1 plus, we replace x by 1. Okay, so x square will become 1 square, right? And therefore 1 square is 1. Okay, so this limit is 1. Now I want to find right hand limit. Okay, so right hand limit means on the number line there is a point x is equal to 1, and I am approaching that point from the right hand side. So I will write limit x tends to 1 plus. So this plus sign is symbolic that we are approaching 1 from the left side. And if we are approaching 1 from the left hand side, we write limit x tends to 1 minus. So I hope you will remember this, right? Okay. So I am taking limit x tends to 1 plus. I am approaching 1 from the right hand side. So for that, I have to take the second part of the function, and I will write limit x tends to 1 plus 2x minus 1, and x will be replaced by 1. So 2 into 1, 2, minus 1 will be 1. Now look here, both the answers are 1 only. So left hand limit and right hand limit, both of them are equal to 1. When they are equal to 1, then we say that the function is continuous at x is equal to 1. So I hope you understood the continuity part. Now let us see the differentiability part. Before we start differentiability part, let me explain to you what is differentiability. So let us see here, testing for differentiability. To test whether a function is differentiable, we first define the left-hand derivative. See, there we had left-hand limit and right-hand limit. Here we have left-hand derivative and right-hand derivative. If you are asked to use the first principle, then you have to use this method. Otherwise, no need of this method. Okay, we will use direct limit and f dash of minus a and f dash of plus a. So this will represent the right hand limit and right hand derivative and the left hand derivative, right? So as you know, we have two parts of the function. So this is the left hand part. So left hand derivative we are going to find here. Okay, left hand derivative. And in this part we are going to find right hand derivative. Okay, so what I will do to this function, first I will differentiate without mentioning right hand or left hand limit. So I'm finding f dash for each part. So x square, you know that it becomes 2x, right? So it is 2x, and 2x minus 1 will become 2 because x will become 1 and 1 will become 0. So 2 is the answer, right? Now, which part is right hand limit and which part is left hand limit? Of course, the first part is left hand limit, left hand derivative. Okay, this is left hand derivative. So I will write f dash of minus 1 because at 1 we are testing. Do you remember here in the question itself it says at x is equal to 1. Okay, so therefore I'm finding the derivative, left hand derivative at 1. So f dash of minus 1. Okay, which will be, we will substitute x, replace x by 1 here. So 2 into 1, which will be 2. Then on the right, for the right hand derivative, in this part I have to replace x by 1, but there is no x, so we will write as it is. So f dash of 1 plus will be 2. Now both the answers are equal. Okay, so left hand derivative and right hand derivative both are equal to 2. Therefore we say that f of x is differentiable at x is equal to 1. Okay, so we say therefore f of x is continuous and differentiable at x is equal to 1. Is that clear? I hope this is clear to you. Now, look here, I wrote a note here so that you remember this thing. A function may be continuous at a given point, but not necessarily differentiable at that point. See, a function may be continuous, but not differentiable at a given point. For that, I am explaining you by second question. I am explaining you this property by second question. I wrote here second question as test for the continuity and differentiability of the following function at x is equal to 2. The function is f of x is equal to absolute value of x minus 2. You know that its graph is like this. At 2 we have the vertex, right? Vertex is at 2 and the two branches are opening up because it is absolute value, so it cannot go down, it will remain positive. So one branch is on the left side and one branch is on the right side. Okay, Left branch is this one. Okay, so let me write there also. Minus x f of x is equal to, so that you understand it well. F of x is equal to minus x plus 2, and this one is f of x is equal to x minus 2. Why like that? See, I am writing the whole thing negative. So my answer will be like this here, because negative means less than 2. So minus x plus 2, and the whole thing I am taking one time positive for this part. So it will remain as it is, x minus 2. Okay. So I hope you understood that part. So branches I wrote so that it will be more clear to you, right? This is one branch and this is second branch, so that it looks good to you, right? Okay. These are the two branches. Don't get confused from the two branches. I don't have two function. I have one function only, which is f of x is equal to absolute value of x minus 2. But it is again a piecewise function. First part is here, second part is here. For x greater than 2, I will get x minus 2 from the absolute value. And for x less than or equal to 2, I will get minus x plus 2 from the absolute value. Right? Now, stage 1, continuity I'll test. Okay? Where I want to test? At x is equal to 2. So again, I will find left hand limit and right hand limit. So limit x tends to 2 minus c. I will approach this 2 from the left side. So I will take limit x tends to 2 minus. Now on the left side, I have this branch. So in this I will substitute, I will replace x by 2. So I am choosing this branch, which is for x less than or equal to 2. In this, I will replace x by 2. So minus 2 plus 2, which will be 0, right? Then for right hand limit, I will approach 2 from the right hand side and I will write limit x tends to 2 plus. Okay, that will be for this branch of the function, this part of the function. So limit x tends to 2 plus f of x will be limit x tends to 2 plus x minus 2. And I will replace x by 2. As I told you already that 2 plus and 2 minus are symbolic. They are not negative or positive values. Okay. So I will replace x by 2. It will become 2 minus 2, 0. So both the answers are equal, 0 and 0. So since f of limit x tends to 2 minus f of x is equal to limit x tends to 2 plus f of x, and both are equal to 0, therefore the function f of x is continuous at x is equal to 2. So I hope you understood this. Okay. Now the next part of the function. Next part is stage 2, differentiability. So again I will write the same function, the right part and the left part from this absolute value. I am taking the whole absolute value one time positive, so I am getting this answer, and the whole absolute value one time negative, so I am getting this answer. Okay. Now I will differentiate it. As I told you in the earlier question also, first we differentiate it as it is. First branch in its place, second branch in its place. So differentiation of this whole thing will be 1 here and 0 here. So I wrote 1. Then differentiating this branch, here I will get negative 1 and here I will get 0. So negative 1. Okay. Now, the left hand derivative and the right hand derivative are like this. This is the right hand derivative. Let me write here right hand derivative. And this is left hand derivative. Okay. So, the right hand derivative f dash of 2 plus will be, because there are no x values, so I have to write the same value. It is a constant function. The derivative is a constant function. Then left hand derivative will be f dash of 2 minus. Again it is a constant function, so it will remain negative 2. But both the answers are different. They are not equal. So therefore, we say that f of x is not differentiable at x is equal to 2. So f of x is continuous but not differentiable at x is equal to 2. So see, as I told you, a function may be continuous but not differentiable necessarily, okay, at the given point. So this is the example of that, because this function is continuous but not differentiable, okay. So I hope you understood from the two examples. I know that I am getting late. So now look here. For your practice, I have put three questions here. Please try to solve them and send me the answer. The answers are already there, the multiple choice questions I have put for you, but you have to solve and write to me which answer is correct. For question number one, from A, B, C, D, you have to choose. For question number two, from A, B, C, D, you have to choose. And for question number three, from A, B, C, D, you have to choose. And send it to me on my WhatsApp here with your name, okay, and which class you are in, AIHL, AAHL, okay, right. So if you like this lesson, please like, share, and subscribe to my YouTube channel so that I get encouragement and I'll make more videos. If you don't subscribe me, if you don't share me, and if you don't like me, then I mean, you know the nature of a person. Anyway, so I'm sure, because I have explained it in a very nice way. So I'm very sure that whoever will watch this lesson, he will like, share, and subscribe to my YouTube channel. So please do so. Okay. You can download the PDF of this lesson from the description of this video. Okay. Okay then. Bye. I hope you understood everything.